Hey everyone, and welcome. We're diving deep into the world of information retrieval today. It's pretty amazing when you think about it. We've gone from hunting for information like it's a needle in a haystack to, well, AI that practically reads your mind.
It really is remarkable how far things have come, and so quickly, too. In just a few decades, we've moved from those early days of basic keyword searches to these incredibly complex systems that can actually grasp the nuances of human language.
It really is mind-blowing. So to really appreciate how we got here, let's rewind the clock back to the 1970s, the early days of computers. Finding information back then was like, I don't know, talking to an extremely literal librarian, right? You had to know exactly what you were looking for or you were out of luck.
Exactly. You absolutely needed the exact words to get anywhere. But then something changed. A real breakthrough TF-IDF.
Okay, so KeyFIDF, term frequency inverse document frequency. It sounds pretty technical.
It does, doesn't it? But it's actually a very elegant solution, if you think about it.
So break it down for us. What's so special about TF-IDF?
Imagine you're searching for information on a specific topic, right? Some words are just general, they pop up everywhere, but others are more specialized, you see them less often. TF-IDF, it realized that those less frequent words, the more specialized ones, well, they're often the key to really understanding what a document is about, what it's really getting at.
So it's about recognizing the words that actually carry the most weight, the real meat of the topic, and not just the everyday common words.
That's it. And back then, that was revolutionary. It meant computers could finally start making judgments about what was relevant, even without an exact keyword match.
So instead of just blindly matching words like a robot, computers could actually, in a way, start to understand the context and be truly helpful.
That's exactly it. And, the impact of that, it's huge. This wasn't just a quick fix. TFF-IDF, it really laid the groundwork for almost everything that came after it.
Wow, that's incredible. Talk about a legacy. But of course, things never stay still for long in the digital world, do they?
You got that right.
The internet was just around the corner, and things were about to get a whole lot more interesting. The 90s, the internet, talk about information overload. It's like we went from a neatly organized library to, I don't know, a jungle of information practically overnight. Millions of websites popping up left and right.
It really was a complete explosion of information, and those early search engines, well, they struggled to make sense of it all.
Yeah, it must have been a nightmare trying to find anything useful in that mess.
Yeah.
So how do we go from that to, well, to what we have today, something that actually works?
Well, that's where two Stanford students, Larry Page and Sergey Brin, enter the picture. They had this radical idea. The key to navigating this new world wasn't just looking at the words on a web page, but actually looking at the links between them.
Ah, the birth of Google
Yeah.
and their secret sauce, that PageRank algorithm. So what was it about PageRank that was so groundbreaking?
PageRank was brilliant because it understood something crucial about the web. It's
Mhm.
all interconnected. Think of it like a giant popularity contest, where each link from one website to another is basically a vote of confidence.
So the more links you have pointing to your website, the more important you must be.
Yeah, exactly. Pages that got more links from other well-connected pages, those were considered more important, more trustworthy.
It's like a digital version of word of mouth.
Right.
The more people recommend you, the more credible you become. And that's how Google used PageRank to take the lead, to become the Google we know today.
Exactly. It wasn't just about finding pages with your keywords anymore, no. It was about figuring out which ones were the most authoritative, the most relevant, based on this whole network of connections.
It's amazing how they took this giant web of links, something that seemed so chaotic at first glance, and turned it into a way to actually organize information and make sense of it all. But even with Google leading the way, the story doesn't end there, does it? The quest for even better information retrieval kept going.
Absolutely. I mean, PageRank was a revolution for finding stuff on the web, but researchers were already digging even deeper, trying to figure out how to go beyond just simple keyword matching. They wanted to understand the deeper meaning behind the words. And that led to some really cool techniques, things like latent semantic analysis, we call it LSA for short, and then later on, latent Dirichlet allocation, or LDA.
Okay, I gotta admit, those names sound a bit intimidating. Can you break those down for us? What were LSA and LDA all about?
Sure, go with it this way, okay? Imagine a massive library, right, with books on absolutely every topic you could imagine, but the books, they're all jumbled up. What LSA and LDA could do, it's like they were these super-powered librarians that could magically organize those books by their themes, by their topics, even if those things weren't explicitly written on the covers or in the titles.
Okay, that's pretty impressive. It sounds like magic, almost. How did they pull that off?
Well, the trick was that instead of just looking at the titles or even the words within a single book, they analyzed the patterns of words across a massive collection of documents.
So instead of just looking at one book at a time, they looked at the whole library as a giant interconnected web of information.
Precisely. So they could notice, for example, that documents mentioning planets, galaxies, black holes, well, those are probably all related to astronomy, right? Even if they never actually use the word astronomy itself.
So it's like they were able to uncover the hidden connections between all these different pieces of information to the underlying themes that tied everything together.
Exactly. And this ability to understand the topics and the themes in text, well, it was a game changer. It paved the way for all sorts of amazing things like those personalized recommendations we see everywhere today. You know, the ones where it seems like the internet is reading your mind based on what you've clicked on or bought before.
It's both amazing and a little creepy at the same time, isn't it? Like, how do they know that? But this is all really just the beginning, right? We're about to enter the age of AI, where things get really wild. It's incredible to think how fast everything we've talked about has developed, and now we're stepping into the world of AI where things get really interesting.
It really is a whole new ballgame. And
Yeah.
one of the big breakthroughs in AI has been this idea of word embeddings. It's like imagine every single word in the English language as a point in space.
Okay, I think I'm following so far.
So words with similar meanings, they're closer together in this space. And words with totally different meanings, those are farther apart.
So like cat and dog would be pretty close together because they're similar concepts, right?
Mhm.
But something like cat and tractor, those would be miles apart.
Exactly, you got it. But here's where it gets really wild. Computers can now use these word embeddings to understand how words relate to each other in a much deeper way than just looking at simple synonyms.
We're not just talking about recognizing that big and large basically mean the same thing anymore.
Right. Computers can start to understand things like analogies, like king is to queen as man is to woman. They can grasp that the relationship between those pairs of words is similar.
Now that is really something. Computers aren't just matching words at a surface level anymore.
Yeah.
They're actually starting to get the deeper connections, the nuances of language, like never before.
Exactly. And that brings us to some of the most mind-blowing stuff happening in AI right now. These large language models, we call them LLMs for short, like BERT and GPT.
LLMs, those are the real heavy hitters in AI, right?
They are, and they're trained on huge amounts of data. Like we're talking billions upon billions of words. And they can understand and even generate human quality text in a way that's just incredible.
These LLMs, it's almost like they can think like us.
It's getting closer and closer to that all the time. It's not just understanding a word here or a sentence there. These LLMs can take in entire paragraphs, even whole documents, and understand the context and meaning in ways we never thought possible before.
That's amazing. So how does all of this play into how we search for information online?
Well, think about it. When you type a question into a search engine, and that search engine is powered by one of these LLMs, it's not just trying to match keywords anymore. No, it's actually trying to figure out what you really mean, to understand the subtleties of your question. It's like having a conversation with, well, an incredibly knowledgeable expert who can give you exactly the information you need.
Wow. It sounds like we've come such a long way from those early days where it felt like we were trying to find a needle in a haystack to AI that practically reads our minds.
It's been quite a journey, and the most exciting part. This is just the beginning. Who knows what the future holds for information retrieval?
It's definitely a fascinating time to be swimming in this ocean of information, and it sounds like we have some pretty powerful tools to help us navigate it all. And on that note, I want to give a huge thank you to you, our amazing listeners, for coming along with us on this deep dive. We'll see you next time.